So we've been talking about the compound angles for a few days. We've talked about drilling. Today we're going to talk about milling, and we're going to look at something like this block here. For this block now, what we've done is we've taken a corner and milled it off like this. So this is just a regular rectangular box or block, and we wanted this corner milled off at an angular surface. And you'll see that the angle goes in both directions from each side. So what we're looking at is, if I can draw this, a block that's been milled like that, with that corner milled off. Now when we do this, we're going to do it similar to the way we did the drilling when we just had the angles. Now obviously this sitting in the mill, if this is the corner here that we want to mill off, we're going to have to put this on some sort of a bevel. You guys have your bevels you can set them on. But again, you're going to have to rotate this, something like that, so that this edge is perpendicular to the mill. And then you're going to have to tilt it on a bevel of some sort here, whether you're using a sine bar or an adjustable bevel, either one, so that now when you set that on, actually I should have the bevel the other way, sorry. So that now when you set that block on the bevel, the angle of that surface is now flat with the mill. So the mill, you can just bring the mill down and mill that surface flat to the ground, and it's the correct bevel. So the angle of rotation is just this angle right here. If you're looking at it from the top, this is our angle of rotation. We have to go from this edge to that edge. Or we could rotate the other way. We could use this as our angle of rotation if we wanted to. It really doesn't matter. And then our angle of tilt is going to be the angle here that we have to set to bring that surface flat. That angle of tilt actually kind of runs, once we have this line parallel or perpendicular, our angle of tilt is perpendicular to that line as well. So there's a little bit more involved in this calculation. So let's draw our picture out here. We're going to do a top view. Something like this. Our front view will then look like that. And our end view something like that. Things we know of, we know of course that depth is going to be the same. If I give you this angle here and this angle here, we can go ahead and find the angles we need for machining this, the rotation and the tilt. I'm going to use this angle as my rotation, and then my tilt again is going to go off of that perpendicular line there. And I'll show you how that's going to work. Let's say I give you angle A here. I'm going to call it angle A and angle B. Let's say I give you that angle A here is 18 degrees, and angle B over here we are going to call 27 degrees. Just like with the drilling, we can pick a depth. All we care about is the area affected by this, so this here is really the depth we're concerned with. We can pick whatever dimension we want for that depth. Let's pick 10 millimeters. Now that we have that 10 millimeters, we can find this dimension here and this dimension here. Over here, this is the 10. I'm going to call this little a and little b. I better be careful. That's not proper notation because they're not across from angles A and B. I'll call this little x and little y. So, little x here, according to angle A, is the adjacent side. The 10 millimeters would be the opposite side. We're dealing with a tangent here. We have the tangent of 18 degrees equals our opposite side, which is the 10 millimeters, over the adjacent side, which is x. So we're going to make this into a proportion, and we'll cross multiply and divide. So that means we have 10 millimeters divided by tangent of 18. Gives us 30.78 millimeters. That is also the dimension up here, by the way. So now here to find y, that's going to be a tangent of the 27 degrees. The opposite side is still the 10 millimeters. Now the adjacent side is the y. Put this over 1, we're going to cross multiply and divide. So now it's 10 millimeters divided by the tangent of 27 degrees. 19.63. Which is also this dimension right here. So that actually gives us the formula, everything we need to know to find r, our rotation. Because if we look at that triangle, if this is r, this is 19.63, and this is 30.78, r is going to be found using what? Inverse tangent. Why isn't it inverse instead of just regular tangent? Because what we're looking, there you go, we're looking for an angle. The opposite side is the 19.63. The adjacent side is 30.78. So it is inverse tangent. Second tangent, 19.63 divided by 30.78. 32.53 degrees. So now, as we're looking at this corner here, there's that missing corner that we machined off. R, we found to be this angle right here. What we now need, let me redraw this a little bit better. This I hope will give us a better angle. So there's that missing corner. What we need is the angle between, if I drew a line on the surface up here, on the top, perpendicular to this top edge, and then I draw a line from where that touches down to here, the angle in between them right there is the angle of tilt. So if I'm looking at it, here's that angle in there that I'm looking for. This here is just going to be our 10 millimeter depth that we put in up here, that depth. That's just this dimension. This top side here is this dimension across here that I have to find yet. That dimension going on this triangle would be from this point over to here at a right angle. So I can find that with the information I have actually pretty quickly. So this was my angle R, which we found to be 32.53 degrees. And this side down here was the side that we found to be 30.78 millimeters. We want this dimension here, but since it's going to form a right angle there, we have another right triangle. So now we can look at this being our right triangle. So what we're looking for over here, I'll call that Z, is just the opposite side according to this angle. This is now the hypotenuse because our right angle's over here. Opposite and hypotenuse make sine. So we have now the sine of 32.53 degrees equals Z over 30.78 millimeters. So we can find Z by doing cross multiply and divide. So sine of 32.53 times 30.78 divided by 1 is 16.55. So that dimension there is 16.55 millimeters. So again, that triangle we just looked at was this top triangle here. We just found this length here. To get the rest of this triangle, flipping it down, what we just found was this top piece. We assumed this was 10 millimeters earlier. Our angle of tilt is right there. So our angle of tilt, we have opposite and adjacent sides, so it's going to be an inverse tangent of 10 over 16.55.
Is the angle of tilt always across from your jets?
Yes. So second tangent of 10 divided by 16.55 gives us 31.14. That is degrees. So what this is saying is for this part, I should be sitting like this. If I'm going to take this corner off here, I'm going to rotate it this far. Once I rotate it that far, now this edge here is going to be perpendicular to the machine, and then I'm going to tilt it this far to bring that surface level to the ground. Does that make sense?
So when you tilt it, you're lifting it up so it's parallel to the floor of the machine.
Exactly. What we're doing is you're taking this block sitting here, this is the top of it. First thing you're doing is you're rotating it like this now so that this edge is perpendicular to the machine itself. And then we're tilting it. So now that this whole surface is flat to the ground so that your mill can come down and just mill flat. So you have a bevel here that's holding this at that tilt. You guys have the bevel vices, don't you? In the shop? Probably. Otherwise, you can just use it. Otherwise, you can just use a sine bar if you need to set it up too. Okay.
Now is the triangle on the opposite side then will be the exact same, that third triangle?
Yeah.
Okay.
It should be. I'm just being lazy here and not redrawing my block quick. So I'm going to bring this down to do our next example. There we go. I'll give you guys a second to redraw it if you need to. But again, we're looking at a top view. Something like that. a front view like that. And an end view similar to that. And let me put in 24 degrees and 33 degrees. Everybody ready? Or need just a couple minutes to draw? I'll give you a little bit to draw. So we have those angles. Just like before, we're going to put in our own depth here. We're going to put in 10 millimeters. So now we can find this dimension here, we'll call X. This dimension here we'll call Y, which happens to be the same. Well, it is this dimension right here. So again, here, to find X, it's the tangent to 24 degrees equals 10 over X. Cross multiply and divide, so it's 10 divided by tangent of 24. It's 22.46. That's millimeters. And then for Y, same thing. Tangent of 33 degrees equals opposite will be 10. Adjacent is Y. Put this over 1, cross multiply and divide. It's 10 divided by the tangent of 33. Giving us 15.40. So now for our rotation here, R is simply the inverse tangent of the opposite side is the 15.40 over the adjacent side is the 22.46. So inverse tangent 15.4 divided by 22.46 gives us 34.44 degrees. So now we're back to this here where we find this length that's perpendicular across there, and we use that to complete this triangle here. So we need to find that blue length first, which comes off of this rotation triangle here. This was our 34.44 degrees. Bless you. This was the 22.46 down here. We need this dimension here. Now again, in this triangle that we've just created, this is the hypotenuse now instead of one of the legs. And what we're looking for here is the opposite leg. So we're dealing with a sine of 34.44 degrees equals that opposite leg over the hypotenuse of 22.46. Everything's kind of switched spots because we're looking at a different triangle now. So now let's cross multiply and divide this way. So that's just going to be the sine of 34.44 times 22.46. Gives us 12.70. Now, we can look at this triangle here. When we pull that out, this top is this diagonal piece here, 12.70 millimeters. This is our depth of 10 millimeters. This is our angle of tilt. So our angle of tilt is the inverse tangent of 10 over 12.7. Which is 38.22 degrees. So we rotate 34.44 degrees, tilt 38.22 degrees, and we can mill that surface. My voice is giving out, so it's getting annoying, that's for sure.